Okay, so this is the last thing that we are reviewing to send you guys off to geometry with, and this is solving equations. So we did an entire unit on solving equations back in semester 1. That was all of unit 2, was all equations all the time. What we are focusing on today is equations that have the variables either on both sides or variables on the same side, and the difference of how we combine those to be able to solve for x. So I put some basic instructions there. We use opposite operations to solve each equation, show all work. If the variables are on the same side of an equation, we can just combine like terms. If the variables are on opposite sides of the equation, I think my camera just froze. Huh. Yeah, I don't know. It stopped moving. If the variables are on opposite sides of the equation, you can use opposite operations to get from one side of the equation to the other. Miss Burgess, you can help him. Perfect. Thank you. Do you have a question, Michaela?
I don't know if you're still recording.
I am. Okay. So, we are going to be solving equations. We're going to be solving for x. So this first one that we've got here, our x's are on opposite sides of the equation. We've got that 7x on the left, and we've got that 6x on the right. So what we're going to do is we are going to use opposite operations to move all of the variables to one side, then we can solve. I like to always either move to the left or move so that I don't have negatives. I'm going to move to the left, and so I don't have negatives. So I'm going to subtract 6x from both sides. 7x minus 6x is 1x. So now I have 1x plus 13 equals, this 6x minus 6x cancels, so then I just have a 7 on the right side of my equation. Okay, from there, I can now take this 1x plus 13 equals 7, and I just need to solve for x. So the next thing that I'm going to do is I am going to subtract 13 from both sides. And that'll give me 1x equals 7 minus 13. 7 minus 13 is negative 6. Then, what I would normally do is I would take the number in front of x and I would divide both sides of my equation by 1. But because 1x is the same as x, I just now know that x equals negative 6. I don't need to redo and divide there. So we moved all of our variables to one side of the equation, and then we used opposite operations to solve for x, just like we did back for the entirety of Unit 2. Any questions on that first equation? Okay. The next one that we've got has variables on one side of the equation. So we've got 6x and negative 3x, but since they are both on the left side of the equation, instead of using opposite operations, we are just able to combine those. So 6x minus 3x is 3x. So now I have 3x minus 10, and that equals 35. Okay, from there, it's a two-step equation, meaning it's two things to get x by itself. I'm going to get rid of that minus 10 by adding 10 to both sides. That gives me 3x equals 35 plus another 10 is 45. Do you have a question?
I have the next step.
All right. Next thing that we do, 3x means 3 times x. What should we do?
Divide.
Divide by 3 on both sides. And then we get x equals, I know that 45 divided by 3 is 15, because if you take 45 minutes and split it up into chunks, you split it up into 3 15-minute chunks. Okay, so there are our first two equations, and the difference in these two equations was, on the first one, our variables were on both sides, so to combine together, we had to do minus 6x to move that 6x to the left. In the second one, our variables were on the same side, so we were able to just combine them. Any questions right now? Okay, the last two equations we have on here, and then I think, is there 6 or 8 on the back? There's just 6 on the back. The last two equations we have on here, I'm adding in distributing, and then I think there's 2 on the back that involve distributing. So if we have parentheses, we need to distribute the number in front of our parentheses into our equation, and then we can do that whole same process. So this next one, I'm going to distribute this 6. So 6 times x and 6 times 3. I'm going to rewrite this 8x minus 6, just the exact same, equals 6 times x is 6x, and then 6 times 3 is 18. And I still have my plus 6x. Okay. Then this one has both variables on the same side, this 6x and 6x, and variables on opposite sides. So I'm going to leave my left side alone still, just rewrite 8x minus 6. And I am now going to combine this 6x and this 6x. 6x plus 6x is 12x. So I now have 12x plus 18 on the right side. So since they were on the same side, I was able to just combine them together. Then, now to get the 8x and the 12x together, I've got to do opposite operations to get them all to one side. So I can either subtract 8x from both sides or subtract 12x from both sides. I'm going to choose to subtract 8x today from both sides because that way I won't have negative numbers. So I'm going to do minus 8x, or at least won't have negative x's. On the left side, that leaves behind a negative 6. And on the right side, 12x minus 8x is 4x. And I still have my 18. Telephone. Hello? Yes. Go. Bye. Okay. Okay, hello again, recorded. All right, so now we've got negative 6 equals 4x plus 18. Sorry about the interruption. We are going to get rid of that positive 18 by subtracting 18 from both sides. Right here, I've got negative 6 minus 18. This means I took $6 from you, and then I took another $18 from you. I have now taken $24 from you. Negative 24 equals 4x. And then the last thing that we need to do is we need to divide everything by 4. That 4 over 4 will cancel here. I'm going to go ahead and put my x on the left side. Negative 24 over 4 will be negative 6. So I get x equals negative 6. Okay, any questions about that one? That one's definitely the longest on the entire assignment because we had to distribute and we had variables on the same side and we had variables on both sides. I don't think that happens again. Okay, our last one then, and I picked out fun colors to write with and then I used black the entire time. That's really boring of me. Okay, last one, we're going to distribute that negative 2. So negative 2 times 10, negative 2 times negative x. So the x out here in front stays the same. Negative 2 times 10 is negative 20. And then negative 2 times negative x, the negative times negative becomes positive. So I get plus 2x, and that equals 35. Did I mess up this problem when I wrote it? I think I might have. Okay, we're going to combine these together. X plus 2x is 3x minus 20 equals 35. I definitely messed up this problem when I wrote it. Sorry, guys. We can add 20 to both sides. Which will leave us 3x equals 55. And then I wanted for this to work out evenly, and it doesn't. Because when we divide by 3 here, 55 divided by 3 is not a whole number, and normally I make it whole numbers, and I'm nearly positive everything on the back is whole numbers because I checked those ones. But I think I changed this one later because I wanted you guys to have to distribute a negative. So I think that's on me for changing that later. But 55 divided by 3 is 18.33. So we'll just go with that for that one. But I don't think that happens on the back. I think everything on the back is a whole number. So there is that. If anyone has any questions, let me know. Otherwise, I'm going to post this video. You guys have 6 problems on the back of this to work on. Me and Miss Burgess will be around to check while you guys are working. You got 6 problems on the back. You guys can go in and get started. Bye, video.